Welcome back to the Explainer. Today, we're going under the hood to look at the massive physical system that moves oil around the planet. It's a network that pretty much operates out of sight, but as we'll see, it affects the price of, well, just about everything. So, yeah, have you ever really thought about that? How does a barrel of crude oil travel from a well, say in the Middle East, all the way to a gas station near you? It's not magic, that's for sure. It's actually a complex logistical ballet governed by steel, by economics, and by the simple, brutal challenge of distance. You can think of this network as the planet's circulatory system for energy. And in this explainer, we're going to trace that flow. We're going to look at the main components, the arteries, the veins, and the economic brain that tells it all where to go. So let's start with the most flexible part of the system, what you might call the arteries. The absolutely massive fleet of oil tankers that are constantly crisscrossing our oceans. Now, what's really interesting here is that this isn't just one big fleet of identical ships. It's highly specialized. You got the big guys, the VLCCs, that's very large crude carriers, and they're the workhorses doing the long-haul trips. Then you have smaller vessels for shorter routes. And this is crucial because you can't just swap one for another. That lack of substitution creates its own unique market dynamics. And that brings us to a really key concept called ton-mile demand. It sounds a bit technical, but the idea is simple. It's not just about how much oil is being shipped, it's about how far it has to travel. So imagine a geopolitical crisis forces ships to take a much longer route. Even if the amount of oil being moved is the same, the shipping market can get incredibly tight really fast. And this quote just nails it. Shipping isn't just some background cost you tack on at the end. It's an active economic force. It's the price of distance, and it basically translates geography into dollars and cents, which determines how easily oil can move around to fix any supply and demand imbalances. And you can see exactly what happens when that price of distance spikes. The cost for oil that's far away just skyrockets. All of a sudden, it becomes way less competitive. And what that does is it effectively shrinks the world. It can trap supply in one region, causing prices to crash there, while another region just a bit further away is screaming for barrels. So here's the bottom line on this part. Freight costs basically decide how connected the global oil market really is. When freight is cheap, it kind of flattens the world. Oil can move easily from anywhere to anywhere. But when freight gets expensive, you get these regional islands where prices can get totally disconnected from the rest of the world. Okay, so we've covered the flexible ocean arteries. Now let's move inland and look at the rigid iron veins that cross our continents, pipelines. And this is where you see a completely different logic at play. Tankers, as we saw, are all about flexibility. You can reroute them. They go wherever the price signals tell them to go. Pipelines, they are the exact opposite. They are fixed, they are rigid. Once you build one, it locks in a trade flow from point A to point B for decades. So you have to ask, what happens when you have this rigid system and something changes? What if a region suddenly starts producing way more oil than its pipelines can handle? This isn't some theoretical question. It's a recurring drama that causes massive price distortions in the real world. And the sequence of events is pretty brutal. First, the supply of oil upstream starts to grow. But the pipeline, well, it can only take so much. It hits its maximum capacity. So the extra oil backs up into local storage tanks. And once those are full, the price just collapses. The local oil has nowhere to go, and you get this crazy situation where there's a glut in one place and a shortage just a few hundred miles away. This whole thing leads to a really powerful concept called path dependence. In simple terms, it means that decisions made 50 years ago about where to lay a piece of pipe are still dictating how the market works today. The system is literally built around this old infrastructure, which makes it super resistant to change. Okay, so we have tankers and we have pipelines. We know how the oil moves, but the billion-dollar question is, what decides where it goes? The answer lies on what you can think of as invisible economic highways. They're called arbitrage corridors. The highway analogy is actually perfect. A highway between, say, a city with too much oil and a city that needs it is only open for business if the economic toll is worth paying. The price difference between the two places has to be big enough to cover the entire cost of transport, the shipping, the insurance, everything, and still leave a profit. If not, the highway is closed. Now, what's really cool is that each of the world's major trading zones has its own kind of personality. The Atlantic Basin is like the system's shock absorber. It's the flexible zone where adjustments happen.
The Mediterranean is a crossroads where east meets west. And Asia, well, Asia is the primary destination. It's a massive demand center that's constantly pulling in oil from all over the world. And the big one, the route that's kind of a barometer for the health of the whole global market, is that long pathway from the Atlantic to Asia. When that economic highway is open, it means the world is connected. It absorbs extra supply from the West. But when the math doesn't work and that corridor closes, markets get fragmented and things can get messy. So let's bring it all together with a simple question. When does a barrel of oil actually make that huge journey from, say, Texas all the way to China? The answer is incredibly simple, but it's the logic that governs billions of dollars in global trade every single day. It only flows when the math works, period. The price in Asia has to be high enough to cover the cost of the oil itself, the tanker, the fuel for the tanker, the insurance, everything. And after all that, there still has to be a profit left over. It really shows how physical logistics and pure economics are just two sides of the same coin. Okay, so let's quickly recap the most important things to take away from all this. First, and this is the big one, the oil market isn't some abstract idea. It's a real physical network of tankers and pipelines. And those physical realities are just as important as supply and demand. So the next time you're filling up your car, remember that the price you're paying is really just the final echo of this massive, invisible journey that's happening all over the planet.
It's the end result of all those things we talked about: tanker costs, pipeline bottlenecks, those arbitrage calculations. Ultimately, the hard realities of geography, infrastructure, and the cost of distance are the fundamental rules of the game. And a lot of the time, they can trump any abstract economic theory.
And that leaves us with a huge question for the future. As this physical system gets older and as the world starts to shift its energy sources, which of these pipelines, these shipping lanes, these choke points, which ones are going to become the critical weak spots of tomorrow? That's the big question. And now you have the framework to think about it. Thanks for watching.